In this video, we're going to learn about function notation. Here we have a function machine, where you take an input and it generates an output. For example, if our input was 7, we'd take 7, times it by 2 to get 14, add 5 to get 19, and that would be our output. So if 7 was the input, 19 is the output. Now what about if our input was algebraic? What if it was x? So if the input is x, you times that by 2 first to get 2x, and then you add 5, so 2x plus 5. So when the input is x, the output is 2x plus 5. This could be written down instead using function notation. We would first of all write f and then some brackets. Inside the brackets we'd place our input, which is x. On the right hand side we'd write 2x plus 5 because that's the output. This is how you would write down this function machine using function notation. The left hand side, f brackets x, we usually pronounce as f of x, which just means there's a function of x. It shouldn't be confused with f times x. There are brackets there, but that's not what it means in this case, it's just a way of writing down a function of x. If we now go back to the numerical example, where the input was 7 and the output was 19, we can write this down with function notation as well. We would write f, but make the input 7 rather than x this time. The output can be generated using 2x plus 5. All we need to do is replace all of the x's with 7's. So it's 2 lots of 7 plus 5. 2 7's are 14, and if you add 5, you get 19, which we knew as our output. Now let's try some questions. So here we've been given a different function, f of x equals 3x minus 1, and first of all we need to calculate f of 2. To do this, we'll write down the function's output again, but instead of x's, write down brackets. So not 3x minus 1, 3 bracket minus 1. Inside the bracket we then just put the input. The input was 2, so we'll place a 2 inside the bracket. So it's 3 times 2, which is 6, and then minus 1. 6 minus 1 is 5. Now let's try f of 8. So again we'll write down 3x minus 1, but change the x's to brackets, so 3 bracket minus 1. And take the input, which is 8, and put that inside the bracket. So 3 8's are 24, and then minus 1. 24 minus 1 is 23. And then the final question, f of negative 4. So we'll write down the output again, 3x minus 1, but change the x's to brackets. So 3 bracket minus 1, and inside the bracket we'll put that negative 4. So we have 3 times negative 4, which is negative 12, and then take away 1. Negative 12 take away 1 is negative 13.
Good afternoon, everyone. In today's class, we are going to look at question 4 of the past papers, and hopefully we get some time to look at question 5 as well. Now, question 4 deals with two main topics, functions and coordinate geometry. Now, you will be getting a question on coordinate geometry and functions, how they bring it. It's up to CXC, but you are expected to find some function values. So this video is supposed to help you understand the concept of function values, and it's just a replacement of x for a number. So wherever we see x in the equation, we replace it by a number and we work our way down to get a constant. So that is basically the gist of function values. In addition to function values, you are expected to know how to find composite functions and, most importantly, the inverse. So I'm just going to show you briefly the composite functions. We're going to the past papers, we will do those, and then we will go to the inverse. So let's look at this video.
In this video we're going to learn about composite functions. Imagine we had a function f of x equals 3x plus 2. That would have a function machine that looked like this. Imagine we had a second function g of x, which was x squared minus 1.
And what a composite function does, it takes two functions and combines it so that it forms one. And I want you to remember that for numbers, we can't replace that for anything. So the only part for you to replace in the function is where there's a letter term or the variable.
That would have a function machine that looks like this. Now imagine we took an input x and put it through the first function machine. We times it by 3 to get 3x. We add 2, which gets you 3x plus 2, and then that's the output of the first function machine. For the next step, we're going to connect the two function machines together to make one massive function machine. This means that the input for the next one is just the output from the previous one, so 3x plus 2. We take 3x plus 2 and square it, and then we take that and subtract 1. This would then be our output. So for this giant function machine, the input is x, and the output is 3x plus 2 all squared, take away 1. So let's recap what we just did. We started with an input x, we applied the function f to it, so we got f of x, and then we had a function g, but rather than having x as the input, we put the output from the previous function. So we put a function within a function, like this. This gave us the answer, 3x plus 2 all squared, take away 1. And this is what's known as a composite function. We wouldn't normally write it with the double brackets on the left-hand side. We'd remove the outer set of brackets. We would pronounce the left-hand side as gf of x, or possibly g of f of x. Now let's try some examples. So we have two functions here, f of x and g of x, and we first of all want to find gf of x.
So
This means we take an input x.
So the key thing is we take the f of x function and we replace it into g of x. So there is no confusion there. The f of x function is replaced in g of x. So you could start by writing x squared minus 5. Then you could erase the x squared and put the entire f of x.
We apply the f function to it, which gets f of x, and then we take the output from that and put it into the g function. The best way to write this down is look at your g function first. So g of x is x squared minus 5. We're going to write that out again, but instead of x's, we write brackets. So it would be bracket squared minus 5. Then inside all of the brackets, you write the whole f function. So f of x is x plus 1, so we write x plus 1 inside that bracket. We then just try and simplify this a bit. So x plus 1 all squared is just x plus 1 times another x plus 1, and don't forget the take away 5 at the end. We can expand this using FOIL, so x times x squared. X times 1 is plus x. 1 times x is plus x. And 1 times 1 is plus 1. And again, don't forget that negative 5. We can simplify this, because x plus x gives you 2x. And plus 1 take 5 gives you negative 4. So that's our answer. What if instead it was fg of x, so the other way around?
So pay particular attention because you will be getting some composite functions, function values and the inverse, right? So let's pay
around. This means you take an input x, you apply the g function to get g of x, and then whatever you get as the output for that, you put into the f function. So this time we write out the f function, but instead of x, write brackets. So f of x is x plus 1, so we'll write bracket plus 1. Then inside those brackets, we put the whole g function. So the g function is x squared plus 5, so that goes inside the bracket. Now we can simplify this one as well. So we have x squared minus 5, and we don't actually need the brackets here, and then plus 1. The negative 5 plus 1 would simplify, so we end up with x squared, take away 4.
I just want you to look at the screen and look at the difference between the two. Now, the first instant, he did g of f. So that simply means that the one closer to the x, that was the replacement into the g function. On the opposite side, we have f g of x. So the g function is replaced into the f of x, right? So that is something that we must know. We must know how to find composite functions, and CXC may go a step further in asking you to find f of g of 2. So you need to be mindful as to how to find the composite function. And also the last but most important part of functions is to find the inverse.
And here's the answer.
So yes, they will bring the inverse and they will ask you to find the function value of the inverse. So it's very basic, and we will spend some time looking at it.
Hello and welcome to this video where we're going to learn about inverse functions. So let's start with a function. I'm going to take f of x equals 7x plus 2. We could draw out a function machine for this function. It would look something like this. And if you take an input, for example 4, you can generate an output by putting it into this function machine. So we start with 4, we multiply by 7, which gives you 28, and then add 2, that gives you 30, and that's your output. So when the input is 4, the output is 30. When we talk about inverse functions, we're looking for a function that reverses this process. So if we were trying to find the inverse function for this one, we could draw out another function machine, but in reverse. So the input's on the right-hand side and the output's on the left-hand side. So we need to try and create a function where we start with 30, but we end up at 4. So what we do is we go backwards through this function, and then every time we get to an operation, we just do the inverse. So we had plus 2 in this box. The inverse of that is subtract 2. So 30 take away 2 is 28. And then we move on to the next box. And this one was multiplied by 7, so the inverse of that is divide by 7. And 28 divided by 7 is 4. And you can see we end up with the output of 4, which was the input of the original function. So the original function was f of x, and the inverse function is written like this, with a negative 1. This simply means the inverse function. You shouldn't confuse that negative 1 with a power negative 1. It doesn't actually act as a number in this scenario, it's just the way we write an inverse function. So if you ever see f with a negative 1 there, of x, this just means inverse f of x. And we actually just worked out this function. We first of all subtracted 2, and then we divided by 7. So we could say inverse f of x equals x minus 2, and then divide by 7. In your exam, you may be given a function and asked to work out its inverse. There is a method that works well for this and means you don't have to draw out those function machines each time. The first step is to write out the function and change the f of x for a y. So the function here is f of x equals 8x minus 5, but I'm going to replace the f of x with a y. Then on to step 2. So step 2 is to replace the x with a y and a y with an x. And this applies to all y's and x's that are in your function. So if you have many x's, all of the x's turn into y's, and any y's turn into x's. In this case, we've just got one of each, so I'm going to replace that y with an x, so it's x equals, and then replace the x with a y, so it's 8y minus 5. And that's...
And the steps are simple. You just replace f of x with y, there's nothing difficult with that. The second step is to interchange x and y. What this means is that wherever you see y in the equation, you replace it with x, and vice versa. So the steps for the inverse, I don't feel we could get anything more simple than this.
That's step 2 complete. Then we move on to step 3, which is to make y the subject. So we need to do a bit of rearranging. First of all, I'm going to add 5 to both sides. If I add 5 to the right-hand side, that will cancel the negative 5 that's there and leave me with 8y. And if I add 5 to the right-hand side, well, there's already an x there, so I just need to add 5 to that, so that's x plus 5. We've got one more step to go. On the right-hand side, I've got 8y, so if I divide both sides by 8, on the right-hand side, 8y divided by 8 is just 1y, and on the left-hand side, I've got x plus 5, and I divide that by 8, that's x plus 5 divided by 8. So step 3 is complete. On to the final step, step 4, is to change the y into inverse f of x. So we can just remove that y and replace it with inverse f of x, And normally when we write functions, we'd write the function bit on the left-hand side. So we can just switch those last two parts around. And here's the answer.
All right, so we're going to write. This example will help us. So you're writing inverse functions. And you're taking on the example here. Go ahead. And the steps as well. Take a few minutes and write it because it will go a long way in helping you finding the inverse in question 4 of the paper, right? Go ahead.
Excuse me, Miss. I just double checking, right? But when you're doing F inverses, you can just put 1 over the number.
So the inverse function.
Yes, no, what you mean, Liam?
It's like when if x is 4, you can just put 1 over 4 and calculate 8 by 1 over 4 minus 5.
Repeat that, I didn't hear it.
If x is equal to 4, can't
Mhm.
I just put 1 over 4, right? And then do 8 by 1 over 4 minus 5?
Yeah,
Okay,
but that is if they ask you to find the function value. So we will compare it when we do the question, because sometimes you are expected to, you have to find the inverse first and then find the answer. So
okay, miss.
we'll compare it when we go to the questions, right?
Okay, miss.
Now, and this goes for the rest of you all. If you have something to ask, something you want to clarify, something you don't know, ask the questions now, because exams are fast approaching, okay? Let me know when you all have finished writing, okay? Is anyone still writing? I'll ask again.
No,
Is
ma'am.
anyone still writing? Yeah. So here we have F and G are defined as follows. So I want you to find the function value for me, which is G of 1/3. Now that is 1 mark, and really and truly, it is not difficult. And then you are required to find the inverse. So and this is taken from May, June 2022. So go ahead, take a couple minutes, book it out. Let's see what you get. All right, for the first one, the answer is 0. You are supposed to be able to secure that mark, right? And that wasn't difficult at all. The next one, Right, the next answer is 2. So this question is taken from the 2023, May-June 2023. You have a lot of parts. The first one I will do for you. For which value of f of x is, which value of x is f of x undefined? A function, so that's right, f of x is undefined when the denominator is equal to 0. So you're going to put for me x plus 2 equal to 0, and you're going to solve for x. So you should be able to do that. Part A and B, simple. Part C, you're going to do it in 2 parts. Step 1, find f of 0. And step 2, you're finding f of that answer in step 1. So go ahead. All right, check your answers against mine and see if you all got those answers, please.
Yes, miss.
Two things I want you to remember. For undefined, if the denominator is 0, if you take your calculator and you divide 3 by 0, you will get an error. So that is what we mean by undefined. It means that the function cannot exist at that value. Another thing is, for this composite function, you will not require to find f of x. Let me repeat that. You will not require to find f of x. What you could have done is find f of 0 and get 3 over 2 or 1.5, and then substitute that into this and get 6 over 7. So even let's say for the exam, you just found f of 0, CXC will give you 1 mark, right? So remember the steps in finding the composite, the function values. That is straightforward. It is correct answer only, meaning that they're only looking for -4, they're only looking for 10. If you don't have that, you're not getting any mark. For part 1 as well, they're looking for -2. If you don't have that, you won't get any mark. For 1 mark part of the question, it is correct answer only, meaning that you are required to just put the correct answer. Right? We're looking for correct answer only. So that was 2 and 1, 3, 4, 5 marks. The next part is you have to work out the composite function, g of h of x. So let me write g of x for you. And they want g inverse. So we still have some parts here. G of x is equal to 4x minus 5, and h of x is equal to x squared minus 1. So they want g of h of x, take h and replace it in g. And then find the inverse of g and g of -2. That should be 2 marks as well. So take a few minutes and work it out.
Delicious. The series of Kenny muted.
All right, sorry about that. All right, so we're doing H into G. What does that mean? It means that you must be able to replace the function h of x into g of x. So you're taking the g of x and you're making a replacement. This is a number. You can't replace nothing for that. This is a number. You have to leave that by itself. So it means that x is my replacement and I am replacing x squared plus 1. Now, look what the question asks, because CXC knows the majority of children could get that. But they ask for the simplest form. So if you put that and you go on to part C, the examiner will give you 1 mark because that is not in the simplest form. You are expected to know that the brackets need to be multiplied. So this is 4x squared plus 4 minus 5. So this is 4x squared minus 1. And this will give you your second mark. G inverse of -2. You let y be equal to g of x. So y is 4x minus 5. You interchange x and y. You make y the subject. You divide both sides by 4. So f in g inverse of x is x plus 5 over 4. G inverse of -2, -2 plus 5 divided by 4. The answer is 3/4. So you get 1 mark for this, and you'll get 1 mark for the answer. Were you all able to get that?
Yes, ma'am.
Yes, ma'am.
So let me see what else we have.
Yeah.
Good job. So for part 2, you are not required to find the composite function fg of x. We could operate smart and we could find g of -3. When we find that answer, you find an f of that answer. The last part is you put in the g of x function equal to 5/2, and you're finding for x. So go ahead. All right. So we're supposed to have some answers by now, right? So the value of f of 9, that is a function value. All you're doing, you're replacing x with 9. So f of 9, 1/3 of 9 plus 4. Well, 1/3 of 9 is 3. So 3 plus 4 is 7. Now when CXC marking, they're only looking for 7, eh? Only 7 will give you the mark, and that is just how it is. 1 mark is correct answer only. I keep saying that. So
Well,
yeah,
if you do the working in your head for the 1 mark, you still get
yeah. But let me don't do the work in we head and leave it up to chance now, Makaya. Because sometimes you might do the work in your head and you might put on the wrong answer, and whoever marking the paper might be a little lenient. But let me try and put down the working, right? So 3 of -3 over -3 plus 1. So this will give us -9 over -2, which is 9 over 2. So if you get this, out of the 2 marks, you will get 1 mark. Then we want to find f of 9 over 2. So 1/3 by 9 over 2 plus 4, 3 into 3, 9. 3 to 9, 3, sorry. So this is 3 over 2 plus 4. This is 1.5 plus 4, which will give us 5.5. So you get the second mark for working out that. Right? And last but not least, determine the value of g of x for when g of x is 5 over 2. So this you can simply cross multiply. So 3x by 2 is 5 by x plus 1. 6x is equal to 5x plus 5. So 6x take away 5x is equal to 5. So x is equal to 5. Now really and truly, this wasn't bad for 2 marks. But they required that you know that you had to put the g of x function equal to 5 over 2. So we have one part again to do, and then we're going to coordinate geometry. This is taken from 2024, May, June. So remember, you are going to take the function and replace it with x minus 2. So wherever you see x, you're going to replace it with x minus 2. right? So we were supposed to get 3, open bracket, x minus 2 plus 1. The question requires you to write your answer in the simplest form. So don't leave it like that, please. You are required to multiply the bracket. 3x minus 6 plus 1. So 3x minus 5 will secure you 2 marks. And the next one is pretty simple. Don't let it look confusing to you. All you're doing, you're replacing x with 3x plus 2. So I like to multiply it using a box. So 3x by 3x is 9x squared. 3x by 2 is 6x. I've finished with the first row. So 2 by 3x is 6x and 2 by 2 is 4. So this is 9x squared plus 6x plus 6x plus 4 plus 10. This is 9x squared plus 12x plus 14. Did you all get that?
Yes, miss.
Yes, miss. Right, so it wasn't bad at all. So we move in quickly. In addition to functions, you will get coordinate geometry. What in coordinate geometry you will get? You will get gradient, midpoint, length of the line, equation of the line, equation of the perpendicular, bisector, parallel, right? So here we have, taken from the 2024, a rectangle. PQRS has a diagonal PR, where P is the point -310 and R is 4, -4. Calculate the length of the line PR. So for writing the formula and for working it out correctly, you'll get 2 marks. Go ahead. All right, check your answer against mine and see if you'll got that.
Yes, sir.
All right. Good job. Is anybody still writing? Is anyone still writing?
No, miss.
No,
This is taken from May, June 2022. Let's see what I have in 2021. All right, we'll come back to that one. Line L is shown on the grid. Write the equation. So go ahead. Let me see where you come up with. I'll give you a couple minutes. Right? So in this question, you are just expected to find the gradient. So you could use 2 points. So 6, 3 and 3, 2. Three minus 2 and 6 minus 3. This is 1/3. And the C-intercept is 1. So there was no need for you to find the equation, right? You could have just written it as 1/3 x plus 1 for 2 marks. All right. The equation of a different line Q is y equal to negative 2x plus 8. It crosses the x-axis. So if it crosses the x-axis, we have an x value and y is 0. So put y equal to 0 and work that out. Similarly, if it crosses the y-axis, then we have 0 and a y value. So here put in x equal to 0. Go ahead. All right, so if I get x equal to 4, they just don't leave it like that, eh? They're asking for something specific, which are the coordinates. So you're required to put 4, 0. Right? Remember that. Similarly, for this one, you are required to put 0, 8. And I do hope that you all got that. The next part of the question says to draw the line Q. And you know that we are required to draw a line using 2 coordinates. We just need 2 coordinates to draw a line. And according to the graph, they want the solutions. So where the 2 lines intersect, that is the solution. So let's do it. So 4, 0, and 0, 8. I will draw the line. And the point where the two lines intersect is the solution to the system of equations, and that point is when x is 3 and y is 2. So this is the answer here. All right, so for drawing the graph, you would have gotten 1 mark, and for stating the solution 3, 2, you would have gotten the second mark. So this is 3, 2. Correct answer only. Let me see if there are any more. So we completed this, completed that, completed that. All right, so we have one more. This is taken from the May-June 2021, I believe, yeah. So they gave you the line L1 in a format which is x plus 2y, which is equal to 10. And you are required to rearrange that and write it in the form y equal to mx plus c. So go ahead, let me see what you come up with for 1 mark. So we're supposed to have 2y is equal to negative x plus 10, but we don't want the equation to say 2y. The equation must say 1y. So we have y is equal to negative a half x plus 5. And having written that, CXC would have given you your 1 mark, right? Remember, 1 mark is correct answer only. 10 divided by 2 is 5. Say the gradient of the line L1. They just want to test your understanding of the gradients. So write something for 1 mark. All right, so you're supposed to recognize that the gradient is negative a half, and that wasn't bad at all. They are asking you to determine the equation of L2. So it is a perpendicular bisector, and it cuts the y-axis at negative 5. So our C value is negative 5. So you are required to state the negative reciprocal of negative a half and write the equation. For 2 marks, I believe, yes. So the gradient of L1 is negative a half. So the gradient of L2, which is the perpendicular bisector, is negative 1 over the gradient of L1. So y is equal to plus minus 5 because it cuts the y-axis at negative 5. And here you will get 2. So check it and see if this is correct. Negative 1 divided by negative a half, you should be able to get 2 there. All right, can anybody verify that this is 2?
Yes, miss.
All right, so we're moving right along. That's the end of question 4. Time is of the essence. So We're going to stop the share. We're going straight on to statistics. We still have 30 minutes again. Let me make it count.
Hello, welcome back to another video. Here we are talking statistics again. Since you're dealing with discrete data that's divided by 3 and the number of 3 times this.
All right. What to expect in question 5? Statistics. What in statistics? Central tendencies. What are the central tendencies? Mean, mode, and median. They could bring it like a frequency distribution where you are required to find it in the form of a table like this, or they could bring it as grouped data. So we're going to look at both cases. So just pay attention for a few minutes.
They scored 3, 5 times 4, and 2 times they scored 5. So that's what the table is saying. And so we can first talk about what the mode is. Now, the mode is that number of goals that has the highest frequency. So we can go through our frequency list and see that the highest frequency here is 12. And then 12 would be associated with 2, which tells us that the highest number of goals, so the 2 here is our mode because it has the highest frequency.
And let's not confuse the 2, right? Please do not write that the mode is 12. The mode is not 12. The mode is the number of goals with the highest frequency. The highest frequency is 12, and that corresponds to the number of goals of 2.
So mode is 2, or you can say the modal number of goals if you're writing it in a sentence. The modal number of goals is 2. Now we're going to go on to calculate the mean. As I said before, there are 40 numbers represented here. So we need to add up just to show. The frequency is 8 plus 10, 18, 20, 30, 33, 35, 40. So 40 numbers are represented in the table, and they're organized into this pattern here. So what we're going to do is to multiply. Instead of writing them out and adding them up, the faster way to do it is simply to multiply it out. So we put an X here and F for frequency, and we're going to simply multiply frequency times X, where X means the number of goals. So let's do that. 0 times 8 here is a 0. 1 times 10 is 10. 2 times 12 is 24. 3 3s are 9. 4 5s are 20. And 2 5s are 10. And now we have the sum of the number of goals. So we can add up that, and once we add that, 10, 30, 50, 60, 73, we realize that we get 73 there. To find our mean, what we do to find our mean is that the mean is equal to the sum of the frequencies times the number of goals over the sum of the frequencies. And that simply gives us 73 divided by 40, and 73 divided by 40, when you punch it in your calculator, gives you approximately 1.8. And that would tell us that the mean number of goals scored is 1.8. Compare that with the mode. The modal number of goals scored is 2, and the mean is 1.8. This is discrete data. You cannot score 1.5 goals. So if you were asked questions about, for example, what is the best method to best central tendency to use, whether it was mean, mode, or median, then this would be a bad one because it's 1.8 and you cannot score 1.8 goals. So for that reason, you probably would choose 2 since you're dealing with discrete data. That question is not asked here, just saying that if you were asked. Now the next one we want to find is the median. And to find the median, we need to find the middle number. Now, if the data is raw, we need to organize it from smallest to lowest. This data is organized already. We established a while ago that there were 40 numbers. And we're not going to write out those 40 numbers. That would take a ridiculous amount of time and a waste of time, actually. But what we can do, there's a method that we can use to locate where the median is. And since this is discrete data, that's important, it's discrete data. So we're going to say 40 plus 1. We add 1 because when you're dealing with discrete data, your value is always the middle data. And so 40 numbers, when you divide 40 numbers in 2, you will get 20 numbers on that side and 20 numbers on that side. And so you'd have to find what number comes in between the 20th and the 21st number. So for that reason, we add 1. So we would say, all right, 40 plus 1 over 2, and that gives us 41 over 2, which is 20.5. And what this tells us is not the median, but what it does is tells us where the median is. So the median is in the 20.5th position. All right, so if you would write out all the numbers, then the median is going to fall in that position. And that's important to remember. Now, you can add the frequencies to see where the 20.5th position is. So if say we start with here, there are 8 zeros plus 10 ones, that's 18 numbers. So the 20th number is going to land among the 2s here. And so the 20.5th position would land among the 2s. And since it's all among the 2s, then that would tell us that our median here would be 2.
So better than that. To get 20.5 is the average of the 20th and the 21st value. If we keep adding, 10 and 8 is 18. We haven't reached position number 20 as yet. But if we add 12, we will get 30. So it means number 20 and number 21 will be 2. So the median will be 2. So you see how this data here is put in a frequency distribution. This is something that they could bring. They could bring it in a frequency distribution for ungrouped data, just like that. Or they could bring it as group data. So we're going to look at both. Now, this one was brought in May, June 2024. So I don't feel they'll bring this. They'll bring it where it is grouped, but we still need to cover our bases, right? So I'm going to give you a few minutes. This is May, June 2024. And you're doing for me mean, mode, and median. Go ahead. All right, for the mode, it is the number of words with the highest frequency, and the number of words with the highest frequency is 5. All right, we are required to find the median. So the median position is a half, 12, 14, 16, 19, and 4, 23. So 23 plus 1. So we are looking at the 12th position. So 8 and 4 is 12. So the 12th position will be 6. To find the mean, we multiply the numbers. So we get 40, 24, 14, 16, 27, 40. So we add those. We divide it by the total, which is 23. This is 161 divided by 23. The answer is 7. Did you all get that?
Yes, miss.
Right. So I don't feel they're bringing on group data like that, but we still need to cover our bases. What I am interested in is this one, where the data is grouped. So let me pay attention.
Table below shows the distribution of masses of packages. So we have packages measuring 1 to 10 kilograms, and there are 12 of them. Packages measuring 11 to 20 kilograms, there are 28 of them. 21 to 30, 30 of them. 31 to 40, etc. We have 22 and 8. So if you wanted to estimate the mean, and it's important here to point out that in this, it's an estimate. For your frequency distribution and for raw data, the mean that you find is the actual mean. But for these group distributions, when you find a mean, it's an estimate. The reason is the data is so grouped that you do not know. It says 12 numbers lie between 1 and 10, but we don't know what those 12 numbers are. They could all be 1s, they could all be 2s, they could all be 1.5s or 9.5s. We don't know. 9.4s rather. We don't know what they are. So all that we know is that there are 12 numbers in this group. There are 28 numbers in that group. And because of that, we have to make an estimate for a midpoint. Now, the midpoint is found by adding these two numbers. They are called the limits. So we add these two numbers and we get a midpoint. And that midpoint will help us to calculate the mean. So the first midpoint here, if you should add 1 plus 10, that gives you 11, and divide 11 by 2. So we'd say 1 plus 10. Let's just make a little column here. So the midpoint, the first one, 1 plus 10 divided by 2, which is 11 divided by 2 is 5.5. And so the midpoint here, this mid is 5.5. And doing the same thing here would give us the other midpoint for that one, which would be 15.5. Continuing, 25.5, 35.5, and 45.5. We're going to be talking more about these in another video in terms of dealing with the particular things behind the group.
So why the midpoint? Because the data is grouped. So we don't know which of the values between 1 to 10 to choose. So the standard is to find the midpoint. Because I am sure if I were to ask you all to choose a number between 1 and 10, you all will choose different numbers. So for grouped frequency distributions, we must find the midpoint.
Grouped distributions, all the little intricacies about them. But for now, when you're going to find the mean, you need to work out a midpoint, and you do that by adding the limits here and dividing by 2. So 1 plus 10 divided by 2, 11 plus 20, that's 31 divided by 2, 41 plus 50, that's 91 divided by 2, and you get these. Now, once we get those midpoints, we can multiply now. So we can say, we can multiply the frequency, which is this. This is a frequency. Frequency times the x, and we get our numbers. So we can multiply 12 by 5.5, plugging that in your calculator. 12 by 5.5 gives you 66. And 28 times 15.5 gives us 434. 30 times 25.5 here gives us 765. 22 times 35.5 gives us 781. And the final one, 8 times 45.5 gives us 364. Now we need to sum these up, we need to add them up. And so the sum of the frequency times that midpoint gives us 2,410. 2,410. Let's write that a little better. Now, the question told us that there are 100 packages, but you could add these frequencies as well, and it would tell you that the sum of f here is 100. Well, the question said 100, so there was no need to add them up. And so our mean is to divide the sum of x. So our mean is the sum of fx over the sum of f here, and that gives us 2,410 divided by 100, which gives us 24.1. So this is how you calculate the mean from a grouped distribution, by estimating the midpoint and multiplying that midpoint by the frequency. The mean in a group distribution, I'm stressing it again, it's always an estimate and not actual. It's an estimate because we do not know the actual values that were recorded in the table. We only know that there are 12 in this group, 28 in that group, and we do not know what the actual numbers are. So when you work out the mean, your mean is always an estimate. Now, what about the model class? Well, the model class is simple. The model class is simply that class or interval that has the most entries. And you'd find that by going down the frequencies and look, and as you go down the frequencies, you'll see that 30 is the highest frequency, which means that 21 to 30 would be your model class. So that's that. That's it. There's nothing else to it. Just pick the class with the highest frequency, and that class is your model class. Finally, we'll talk about the median. Their CXC does not ask the student at the CSEC level to work out the median from the table. What you will do, however, is that you will work out the median from the cumulative frequency curve. There is a way to find the median from the table.
So what he's saying, CXC will never ask you to do a calculation for the median. You are required to use the cumulative frequency or the ogive curve to find the median, right? So we want to look at one question before we go, looking at group data and finding the estimate of the mean. And this one is taken from May, June 2022. I strongly believe we will get a table similar to this. So they're asking for the estimate of the mean. So you have the table there. They give you the first row there, and you're expected to complete it. It is 3 marks. So as best as you could, let's work out the mean. Go ahead. All right, let me know when you have an answer. All right, I got 122.1. Did you work it out to one decimal place?
Yes, miss.